Hello, good morning students. Welcome to BYJU'S exam prep. Very good morning all of you. I hope everyone is good, fine and practicing the ISRO previous year questions, and also you are following this practice series for improving your understanding in the different subjects. Okay, so very good morning all of you. Before starting the session, please do let me know whether my audio and video is all good, all perfect and no doubt or no difficulty. So please do share this video also, so that every students, those who are practicing or those are preparing for ISRO examination, they will be getting this notification and they will be joining as soon as possible, because more the students, more practice, more competition, and that is our objective, so that in this entire series you will be able to practice a lot many questions. And today we'll be taking three subjects: industrial, engineering mechanics and theory of machines. I've taken a less weightage for IE. The reason being, in ISRO examination the IE weightage is very less, so a majority of the questions will be from engineering mechanics and your theory of machine. Okay, so I hope so everyone is good, perfect, and shall we begin with the session? Good morning everyone, very good morning. Good morning. Okay, so I hope everyone has connected with me, and those who are not yet connected, do join this Telegram channel, that is Mechanical by Suraj, so that you can get all the updates regarding the sessions and notification, right? And it's a very important update. On 4th of July at 7:30, Sanjay Rathi sir will be coming up live, the experienced faculty ex-IAS officer. He'll be telling about the right preparation strategy to get the rank under 100 in 2024, and this is a very interesting one. There is a reason being, he is already qualified ESC 3 times, and definitely he has cracked gate many number of times, so he will be giving you the best guidance to get a single digit rank in gate 2024. Okay, fine, and the link will be there in the description box that you can join. And also I will write to tell you very important information that we have started 50 marks series, जिसमें you will be getting पक्का 50 marks 40 days का crash course है, which is gonna start from today onwards. And those who are not subscribed to this channel, कर लीजिए, because there are a lot many series waiting for you before the gate examination. I can surely say, before the gate examination, multiple subjects, multiple number of times will be revised, n number of times. ठीक है, तो ये बहुत interesting भी होगा, that if you are getting these many free sessions on YT, best hai, do subscribe. And this is the complete timetable for this schedule. Like today Abhinav will be coming up live at around 9 p.m. and he'll be talking about the strength of material, elastic constant and thermal stresses. Then Dheeraj sir will be coming after 2 days with more circle. Then again Chandra sir with FM. So these are the complete we can say schedule for mechanical and civil, SOM and fluid mechanics combination. 4 faculties: Chandra sir, Joshi sir, Dheeraj sir and Abhinav Negi sir. Okay, good morning Kiran, good morning. So shall we begin with the today's session? Yes, okay. Let's proceed. The first question on the screen is from the theory of machine. In a Hartnell governor, the mass of each ball is 2.5 kg and the maximum and the minimum speeds are 10 radian per second and 8 radian per second. The maximum and the minimum radii of rotation are 20 and 1 centimeter respectively. The length of the horizontal and vertical arms of the bell and crank is 10 and 20. Neglecting the obliquity of the arms, what will be the lift in the sleeve? Very easy question from the concept of governors. From the concept of governor, if you have seen this year's mains paper also, they have asked a question from Hartnell governor, but there they have said that obliquity is not being neglected, and that makes the problem to be a very interesting in mains paper. Okay, normally in MCQs and objective papers, normally we are getting obliquity to be neglected. Okay, so very good morning all of you. Please do let me know what is the answer for the first question on the screen. There are 24 questions from the 3 subjects: engineering mechanics, IE and theory of machine. 3 centimeter, 6 centimeter, 5 centimeter or 9 centimeter. Quickly, what will be the height of the sleeve? If you remember, there's a simple formulation. Height of the sleeve is equal to your A by B divided by R1 minus R2, where A is the length of the upper. Like if you have seen the Hartnell governor, this is your bell crank lever. Okay, this is your bell crank lever. This is your, I'm drawing only the half portion. Okay, this will be, let me draw it completely. Okay, this is the pivot point. So this is A, this is B, right? and the R1 and R2 are the extreme radii of rotation. So we can easily calculate what is the lift of the arm quickly. What is the lift? And I hope so you are getting this formulation. कैसे निकलता है? I hope you know, everyone. So A value is 20, A value is 10, B value is 20, right? Horizontal and vertical arm 10 and 20. R1 minus R2, this is 10 centimeter, I think. It won't be 1. So 20 minus 10, that is equal to 10. This is radii of rotation. This is 14, not 10. This is 14. Sorry for that. This is 14, है ना? So 14, this is your 6. So 10 into 6 by 20, that is equal to 3 centimeter. It was 14 centimeter, right? That is the reason many of the students were not getting the answer. If this would have been 1 centimeter, then you will be having different answer. If this would have been 10 centimeter, this would have been a different answer. And I hope so you are getting this formulation is, if I said this is the Hartnell governor, ये आपका spring है, this is the sleeve, right? This is your bell crank lever. Okay, so what happens is, if you take the two extreme positions, let's say this is the first extreme position and this is the second extreme position of the bell crank lever. So this is the H, this one will be R1 minus R2, right? This will be R1 minus R2. So if you take, this is A, this is A, this is B, this is B. So if you take these two triangles, this one and this one, these two triangles are similar triangle. So I can say H by R1 minus R2 is equal to A by B, or height of the sleeve or lift of the sleeve is equal to A by B into R1 minus R2. By this formulation, by this small derivation, you are able to calculate this. So we are getting 3 centimeter. Option A is the correct answer for the first question on the screen. Very good, Kiran. Very good. Pagal world, clear hai? Done. Chaliye, next question from the gyroscope. If the air screw of an airplane rotates clockwise when you view from the rear side, an airplane takes a left turn, then what will be the gyroscopic effect? If there is an airplane, right? If there is an airplane, okay, and that airplane is taking a left turn, and you're viewing from the rear side, rotating clockwise, then what will be the gyroscopic effect? Option A, tend to raise the tail and depress the nose, tend to raise the nose and depress the tail, tilt the airplane about the spin axis, none of the above. A, B, C or D. You are viewing an aeroplane from the rear side, it is rotating clockwise, the rotor is rotating clockwise direction, and if the airplane is taking a left turn, then what will be the gyroscopic effect? This type of question is being very frequently asked in many examination, ISRO or ESC. This type of questions being repeatedly asked. A, B, C, D. देखो, C and D is not possible. C and D is not possible, right? Quickly, the airplane is taking a left turn. A, B, C or D. Done, Kiran, world. देखो, very easy. If I say this is the airplane, this is the front side, this is the rear side. You are viewing from the rear side, it is rotating a clockwise direction. This is clockwise, है ना? ठीक है, fine. So you are taking a left turn. The left turn will be, thumb will be pointing towards me. This is the active couple. हमें reactive से मतलब है, reactive will be this. So it tend to raise the nose. It will tend to raise the nose and depress the tail. Option B is the correct answer. Very good, Naruto, correct. अच्छा, गवर्नर भी पढ़ा नहीं है. Okay, चलो कोई दिक्कत नहीं है. ठीक है. So nose is trying to lift up and the tail is going downwards. So option B is the correct answer. ठीक है, clear, correct. Kiran, I hope so this is clear. World gyroscope तो पढ़ा था ना? हाँ, चलो, option B correct है. Let's move to the question number 3 on the screen from a very interesting segment. ध्यान से पढ़िएगा. In figure, the velocities are in ground frame and cylinder performing pure rolling on the plank. Pure rolling on the plank. What will be the velocity at point A? That means there is a roller, there is a cylinder being kept on a plank. The plank is moving with a velocity of Vp. The plank is moving with a velocity of Vp, and Vc is the linear velocity. Like this is your Vc, this is your Vp. They're asking what is the velocity at point A. चलिए, simple question. Interesting है but simple है. Vinay, A, B. Okay, B. Tell me one thing. If the plaque is having a velocity Vp, will that have any effect at point A? Yes or no? बिल्कुल होगा यार. If the ground is moving, right? If the ground is moving, so definitely it will be having an impact at point A also. Okay, fine. So if you try to draw the FBD, or not FBD, the we can say what will be the force at this point. This is your, let us suppose omega. It is rotating with an angular velocity of omega, right? So can we say at this point, at point A, we'll be having this velocity as vc plus r omega, vc plus r omega, है ना? It will be having vc plus r omega, right? And at this point, let us suppose I'm having the net velocity in the right hand side direction, that is vc minus r omega. Yes, if vp was 0, then vc minus r omega would have been 0 velocity. Because this is making a pure rolling motion, right? So at point, let's say the point of contact, can we say the net velocity will be equal to 0? Can we say at net velocity will be equal to 0, and at point of contact we can say vc minus r omega is equal to vp, because the total velocity at this point should be equal to 0. Point of contact पे there will be a 0 velocity, so vc minus r omega should be equal to 0, but the bottom is also moving with the velocity, so it will be having the same velocity as that of vp. नहीं तो slipping होगा, then we'll be having slipping, and we know that pure rolling motion में there is no slipping. Whatever velocity we are having, right, the same velocity will be equal to vp. So from here I can say r omega is equal to vc minus vp. Now what is the velocity at point A? Velocity at point A is equal to vc plus r omega. So vc plus r omega is vc minus vp. So this is 2vc minus vp. This is the net velocity at point. This is the net velocity at point A, 2vc minus vp. Option C is the correct answer. Okay, clear? Because if, let us suppose, try to assume that if the Vp was stationary, if the ground was stationary, so definitely you will be having Va is equal to 2Vc. We have seen that twice of the radius into omega. But because the ground is also having a velocity, so we have to consider that velocity into existence. So how we can consider? Because at the point of contact, the net velocity should be equal. So Vc minus r omega should be equal to Vp. From there we have calculated the value of r omega, and Va is equal to Vc plus r omega. So from there I am getting the net velocity at point A. That is option number C. Okay, clear? Nitish, World, Vinay, Pavan, Mani, Naruto, everyone, clear hai ye cheez? This is a very interesting one. That's why I told you at the starting of this problem, this is an interesting one. Try to apply the simple concept. It's all about relative velocity. That's it. Okay, done. C option. Everyone is getting option C. Chalo, let's proceed to the next question on the screen from the governor also. The controlling force curve of a spring-loaded governor is given by an equation F is equal to AR minus C, where A and C are constant and R is a radius of rotation. What will be the type of governor? Is it a stable, unstable, isochronous, or insensitive? This is the most frequently or the most easiest question that you have in the last year gate, or last to last year gate, a question was asked from this topic. Option A, very good. FC is equal to AR minus C, or AR minus B is for stable governor. Okay, FC is equal to AR plus C, that will be for unstable governor, right? And for FC is equal to AR, that is for isochronous governor. Isochronous governor, right? Okay, fine. So in this problem they are saying FC is equal to AR minus C. If you try to plot it over here, this is FC, this is R, this is your stable, this is isochronous, this is unstable, right? Perfect. Question number 5th on the screen. Try to apply the short technique whenever you're getting a question like this from crank and slotted. Okay, a figure given below shows a crank and slotted quick return mechanism. The crank BC, so we are having a crank BC. Okay, this is your crank, this is your crank, right? And it is having a length of 30 mm. The quick return ratio is equal to 2. The quick return ratio is equal to 2. This is your connecting rod that is being fixed. They are saying what is the length of AC. Can you tell me the answer? Apply the simple logic. Direct calculate करेंगे. 30, 60, 90 or 120. 30, 60, 90 or 120. Simple question from the concept of inversion, single slider inversion. Simple. Very good, very good, very good. B, everyone is getting option B. Perfect, perfect. Option B correct. Very good. देखो simple है. If you try to visualize, remember one thing. It's a short technique. In a crank and slotted lever, if your quick return ratio is equal to 2, that simply means that the length of the connecting rod, will be equal to twice of the radius of the crank. Always remember that. I'll be showing that also. So here they are saying the radius of the crank is 30. So 2 into 30, that is equal to 60 centimeter. Okay, 60 centimeter. If you try to visualize, this is your crank, this is your crank, this is your connecting rod, this is your this is CAB, connecting rod being fixed, this is your crank rotating. Okay, this is, let us suppose, alpha by 2. Okay, so here we are saying your beta by alpha is equal to 2. So beta is equal to 2 alpha. Alpha plus beta is equal to 360 degree. So your alpha is equal to 120. That means alpha by 2 is equal to 60 degree, right? If this is 60 degree, BC is given as 30. So cos 60 is equal to your BC by AC. So from here, AC is equal to BC is 30 divided by cos 60, that is equal to 60 centimeter. Okay, a simple technique for the students, those who don't know the short value. Always remember that whenever the quick return ratio is equal to 2, by default you can say, when very interesting, the length of connecting rod is equal to the twice of radius of crank. Okay, clear? Done. Whenever you're getting any question from objective problem, you can directly use this formulation. Okay, next question, question number 6. A pinion with 30 number of teeth and is driven by a gear of wheel 120 number of teeth rotating with an angular velocity of 60 radian per second. The pair is having a pressure angle of 20 degree and the module of 6 mm. What will be the pitch line velocity? So the number of teeth of the pinion is given, which is driven by a gear, right? And the angular velocity is given as 6 radian per second. Then what will be the pitch line velocity? Quickly. Question number 6, very easy question. 2160, 1080, 4320, or option D, none of the above. A, B, C, or D. This is your gear. This is your pinion. Okay, this is 30 number of teeth. This is 120 number of teeth. Okay, 6 radian per second. Quickly, is driven by a gear having 120 number of teeth rotating. Acha. So they are saying that the angular velocity of the gear is equal to 6 radian per second. Module is equal to 6 mm. What will be the pitch line velocity? So simple, we can see, we can calculate the value of radius. Let us suppose if this is rotating like this, this is rotating like this, the pitch line velocity. What's the meaning of pitch line velocity? This is the pitch line velocity. Okay, so we can easily calculate now. So what is the radius? Radius equal to m into capital T by 2. So this is 6 into 120 by 2, that is equal to 60, that is 360 mm. Okay, so the pitch line velocity is equal to r into omega. So 360 into 6 18,32160 mm per second. Are we getting option A? Very good. Option A is the correct answer. Here the confusion will be whether we need to take the radii of the gear or the pinion. So read the question carefully. They have given that this wheel, it is rotating with an angular velocity of 6 radian per second. So from there we can calculate this one. Okay. Option A, 2160 is the correct answer. Clear everyone? Okay, next question on the screen. Question number 7. A flywheel has a mass of 300 kg and the radius of gyration is given as 1 meter. It is given a spin of 100 rpm about its horizontal axis. The whole assembly rotates about a vertical axis at a rpm of or angular velocity of 6 radian per second. What is the gyroscopic couple? Very easy. They're given in the terms of pi. So I think that won't be having any issue in solving this problem. Omega is equal to 2 pi 100 by 60, right? Omega p is equal to 6 radian per second. Moment of inertia is mk square, that is 300 into 1 square. So gyroscopic couple is equal to I into omega p. This is 300 into 2 pi into 100 by 60 into 6. So this get cancelled, this get cancelled. So 1, 2, 3, 6 pi kilonewton meter. Option A. Option A. Oh, sorry, 6 pi. Option B. 6 pi, na? Option B. 6 pi kilonewton meter. Clear? 6 pi kilonewton meter is the final correct answer. B is the correct answer. Done? Done? Can we proceed to the next problem? Chaliye, next question on the screen from the concept of flywheel. Chaliye. A flywheel has a mean kinetic energy of rotation equal to, the kinetic energy of the flywheel is equal to 100 Newton meter. The coefficient of fluctuation of speed is 0.012. What will be the maximum fluctuation of energy? What will be the maximum fluctuation of energy? Delta E nikalna hai, kinetic energy is given, CS value is given. Quickly do let me know what will be the maximum fluctuation of energy. Is there any formulation from which we can calculate delta E from kinetic energy and the coefficient of fluctuation of speed? If you know, you can directly apply. Very good, very good. Kiran, world, correct. Vinay, Naruto, Nitish, Mani, A, B, C or D. Correct. The correct answer is option B, 2.4 Newton meter. We know that delta E is equal to I omega square CS and kinetic energy is equal to half into I into omega square. So by using this equation, we can say delta E is equal to 2E, this will be 2E CS. Okay. Yes. I omega square CS, I omega square ke jagah 2E by CS, right? Okay, so we can say 2 into E into CS. So 2 into E kitna 100 into 0.012, that is 2.4 Newton meter. Option B is the correct answer. Very good, Pawan, very good. ठीक है, चलिए 9th question on the screen. 9th very easy है. Which of the following mechanism represents an inversion of a single slider crank chain? Which of the following mechanism represents an inversion of a single slider crank chain? Epicyclic, Oldham's coupling, Whitworth or pantograph? A, B, C or D? Very good. Option C is the correct answer. These two are the inversions of a double slider. These two are the inversions of the double slider. This is an we can say an example of an approximate straight line motion. Approximate straight line motion mechanism. Okay, fine. Option C. Can you tell me pantograph is being used where? Where we are using pantograph? Any practical examples that you might have come across? Pantograph mechanism. Anyone who has seen? It is basically being used on the overhead. You might have seen on trains structure like this. Hai You might have seen a structure like this. So this particular is a pantograph mechanism. It follows a pantograph because this is an approximate straight line motion mechanism. On the train which is connected with the high tension cables, right? The mechanism that we are using is pantograph. Exactly. Very good, Nitish. Very good. Perfect. Chalo. Next question on the screen. Bevel gear having equal number of teeth, equal pitch angle connected orthogonally intersecting shafts. This system of gears is known as crown gear, hypoid gears, worm gear, or meter gears. So basically we are having two bevel gears which are connected orthogonally. Same number of teeth. This type of gear we call it as option D, meter gears. Option D, Vinay, not crown gears. Meter gears is having a property like it is only being used to change the direction. If this is rotating with an RPM n, this is also will be rotating with an angular velocity or RPM n, right? Because equal number of teeth. Bevel, this meter gear is being used only to change the direction by an angle of 90 degree. That's it. Option D is the correct answer. Okay, done. Next, question number 11. Let's now try to solve some questions from engineering mechanics. A block of mass 1 kg lies on a horizontal surface in a truck. The coefficient of static friction between the block and the surface is 0.6. The acceleration of the truck is 5 meter per second square. What will be the frictional force acting on the block? So basically this is the block that we are talking about. Okay, and this is the truck which is moving with an acceleration of A. Right, this is your block. Let's say this is mass m. What will be the coefficient? What will be the frictional force acting between the block? A 5.88, option B 5 Newton, option C is 4.33, or option D 0 Newton. There's a block being kept on the truck. Truck is moving with an acceleration of A. So if you try to draw the FBD, what will be the direction of friction on the block? What will be the direction of friction on the block? If you try to draw the free body diagram of M, what will be the frictional force? It's quite easily visible that there will be a friction force on the right hand side direction. This will be your normal reaction. This is your W. Okay. So overall we can say there's a total friction force and that will be responsible for the motion. Okay. Right. And can we simply say on the lower body, this is acceleration, so the friction force will be equal to mass into acceleration, right? So this is 1A is given as 5, so friction force is 5 Newton, right? Okay, but we have to check what is the limiting friction, that we need to check, right? So the limiting friction is equal to mu into N, mu into W. So mu is 0.6, W is 1 kg, 1 into 9.81, so this is near about this 848, 450, 5.88 Newton. Approximately the limiting friction is 5.88 Newton, right? So limiting friction is 5.88 and the friction force acting is 5 Newton. Can you tell me this is a static condition or dynamic condition? This we are talking about the static or dynamic. That means the block will be staying at that position like stationary, or it will be in a dynamic position. That means between these surface of the block will be having any relative motion or not. Exactly, it will be in the static. That means there will not be any relative motion between the block and the surface. There will not be any relative motion between the block and the surface because the static limiting friction is 5.88. I need to have at least force minimum 5.88 or more than that force need to be applied. So option B is the correct answer. 5 Newton is the frictional force acting on the block. Okay, done. Option B is the correct answer. Very good, very good. Limiting friction is more than that of the applied friction, so definitely that will be a static friction, a static condition. Okay, next question. A truss F A, E, F, B, D, C is loaded as shown in the figure. What is the force in the member CF? Okay, so what is the force in the member CF? I hope so now you are able to see the diagram clearly. what is the force in the member CF? Quickly. Do I need to apply method of section or method of joint? You need to calculate the force over here in the member CF, that diagonal one. Definitely, without any doubt, we need to apply the concept of your method of section, right? Or else it will be a time consuming problem. First of all, tell me what will be the reaction forces at A and D? A and B. What will be the reaction forces at A and B? Quickly do let me know in the comment section. And please do like the video, guys. I want everyone to be having a 1:1 ratio, the like wala proportion. You can see this is a symmetrical body, 2W acting downward. Can we say the reaction at point A will be upward W and at point B will be upward W? They got 2W acting downward, है ना? 2W acting downward. So definitely the reaction at point A and B will be this. So we can take a section. We can take a section over here. So this is your FEF. This is FCF. I'm removing the right hand side. And this is FCD. FCD. Quickly, what is the force in the member FCF? This is A, this is A. Let's say this is theta. Theta is equal to 45 degree. Quickly, what will be the value of the force in the member CF? Is it W? Is it 2W? Or is it C root 2W? Or option D 0? W, 2W, root 2W, or option D 0? A, B, C, or D? If you see the total vertical force equal to 0, you can say like this. So FCF sine theta is equal to W acting downward, W acting upward. So this is 0. So that means FCF is equal to 0. That's it. This is a 0 force member. Why you are taking so much of time to solve this? I've already given you a simple technique. Calculate the reaction forces. Then you can say total vertical force. Only FCF is acting upward. W acting downward. This one is acting downward, this is acting upward. So definitely this W and this W will be cancelling out. So FCF is actually a 0 force member. Option D is the correct answer. Option D is the correct answer. Clear? Nitesh, Kiran, Naruto, Prakash, Mani, Pavan, Vinay. Done everyone? Question was very easy. Only thing, just you need to apply the concept of method of section. That's it. And remember one thing, in ISRO examination, if they're asking a question from Truss's topic, it won't be a very complicated one, right? It will be a direct straightforward. So try to apply your concept simply, right? If you're taking many time for calculation, that means your approach is not appropriate. Remember that. ISRO made difficult questions, but the calculative questions nahi aate. Okay. Chalo, next question. Before proceeding to the next question, let me quickly remind you about the series that is being started. Today we'll be having the first class, 50 marks confirmed, 40 days में 50 marks starting from today onwards, and strength of material is the first subject that will be started, and after that fluid mechanics will be started on 10th of July. So complete one by one, 1 week, one subject will be there, and by this sequence we'll be able to cover very easily 40 days में 50 marks. Okay, make sure you are able to see the schedule properly, and it is already being there on our YouTube community post also. You can see from there also. Okay, a body moving in a circular path with a constant speed has, simple question, a body moving in a circular path with a constant speed has constant velocity, constant momentum, constant kinetic energy, or constant acceleration. Let's see what will be which of the option will be correct. If a body is moving in a circular path with constant speed, which of the following option is correct? Very good, Vinay. Correct. Because if you see, if you are moving in a circular path, if any body is moving on a circular path, right? Let's say this is the body moving in a circular path. So at each and every point, the direction is changing. That means the velocity is changing. It's not constant. It is direction is changing. If velocity direction is changing, can we simply say all these three options won't be possible? Constant acceleration, because डायरेक्शन चेंज की वजह से वेलोसिटी विल बी, बिकॉज वेलोसिटी इज अ वेक्टर क्वांटिटी. Magnitude is not changing, direction is changing. So due to that, which acceleration will be coming into existence? इस particular statement की वजह से there will be one constant acceleration coming. Will be tangential or radial acceleration? That will be simply radial acceleration, and that will be towards the center. Okay, clear है? Understood? Towards the center will be the direction of that radial acceleration. Tangential कब आता है? When you are having an angular acceleration. तब आपका टेंजेंशियल आता है, जब मैग्नीट्यूड इज आल्सो चेंजिंग. ओके फाइन. ड्यू टू द चेंज इन डायरेक्शन रेडियल इज कमिंग इनटू एग्जिस्टेंस, एंड ड्यू टू चेंज इन द मैग्नीट्यूड द टेंजेंशियल लीनियर एक्सेलरेशन विल कमिंग इनटू एग्जिस्टेंस. चलिए नेक्स्ट क्वेश्चन ऑन द स्क्रीन फ्रॉम द कंसेप्ट ऑफ थ्योरी ऑफ मशीन, सॉरी योर इंजीनियरिंग मैकेनिक्स. A 13-meter long ladder is placed against a smooth vertical wall. So let's say this is the vertical wall. This is the ladder. Okay, let's say this is, I'm taking it as point A and this as point B, right? With its lower end 5 meter from the wall. This is 5 meter, 13 meter long. This is 13 meter. That means that height will be 12 meter. That height will be 12 meter. So they're saying that what should be the coefficient of friction between the ladder and the floor so that the ladder remains in equilibrium condition. लैडर अगर इक्विलिब्रियम कंडीशन में होना चाहिए, देन व्हाट शुड बी द म्यू वैल्यू? 0.29, 0.35, 0.41 और 0.1. A, B, C or D? A, B, C or D? Okay, let us try to do the FBD of this ladder. Will be having a normal reaction. Acha, do we have any friction force on the vertical wall? Do we have any frictional force at the vertical wall? Yes or no? The answer is big no, because they are saying a smooth vertical wall, right? And this is trying to move in the right hand side. The friction force will be in the left hand side. This will be the direction of friction force at point B. Okay, this will be the center W, right? So this is the complete FBD, है ना? This is the complete FBD. So try to apply the moment about point B. Calculate NA. NA निकल जाएगा तो FB निकल जाएगा, and the NB is equal to W. So वहां से you can get the value of mu. Very good, Arnav, very good. Calculate moment about point. Calculate moment about point your B, है ना? You take moment about point B and make it equal to 0. If you take moment about point B, this will be equal to NA into 12, है ना, is equal to W into 2.5. तो यहां से NA will be equal to W into 2.5 by 12. Okay, now taking all the vertical force equal to 0. If you take all the vertical force equal to 0, your W will be equal to NB, right? If you take all the horizontal force equal to 0, then NA will be equal to FB. NA is equal to FB, but FB is equal to mu B into NB. NB is equal to your W, so mu B into W. NA is already we have seen, that is W into 2.5 by 12. W get cancelled out, so mu B is equal to 2.5 by 12. So it should be somewhere around 0.208 something. Yes, are we getting this? The coefficient of friction that we are getting is somewhere around 0.208. 24 to 0.2, 10, 0, 8, 96. So 0.208, option approximately we can say option A is the correct answer. It should be 0.2, right? So nearest value is option A. It should be 0.008. 0.29 अगर बोलेंगे है ना, it should be 0.21. The correct answer should be 0.21 or 0.208. Option A is the correct answer. Very good. Next question, question number 15th on the screen. A very easy question from the concept of equilibrium. A ball of weight 100 Newton is tied to a smooth vertical wall by a cord making an angle of 30 degree. So let's say this is the vertical wall, right? And this is your cord which is making an angle of 30 degree. It will be having a tension T, this will be having a weight W. What's the tension in the cord? Very simple question. Very easy question. This is 30, this is also 30. So T cos 30 is equal to W. So T is equal to W by cos 30. W is 100 Newton, 100 by, this is root 3 by 2. That is 200 by root 3 Newton. Option B is the correct answer. Very good. Option B is the correct answer. A simple question from the equilibrium. Equilibrium के देखो questions आते हैं, so we are very confident enough. We have solved numerous questions, है ना? बहुत सारे questions हमने solve कर रखे हैं. So you should not be having any difficulty in solving any question from equilibrium conditions. Okay, next question, question number 16 on the screen. Very easy, very interesting. A rod of length L is hinged from one end. Okay, let's say this is the rod. It is brought to a horizontal position and released. So when it is being released, what would be the angular velocity of the rod when it is at vertical position? So basically this is your, let us suppose there is a hinge point. This is the rod having a length L, right? So when it is being released, it reaches the vertical position. Then what will be the angular velocity when it's at vertical position? Energy conservation. Let's apply the energy conservation and get the answer. Yes, Arnab, Kiran, World, Vinay, Naruto, Nitish, Mani. You can use a simple concept of energy conservation. Okay, quickly, what will be the answer to this problem? At the initial position, because we are releasing, that means there is no angular velocity. Okay, so I can simply say the energy will be equal to mgl. If I'm taking this as reference, so mgl will be the potential energy. It has reached, this is the CG point. This will be mgl by 2 plus half I omega square. So this is mgl by 2 is equal to half I omega square. Now this rod is hinged at this point. What is the moment of inertia? Moment of inertia about one of these ends will be equal to ml square by 3. The moment of inertia, mass moment of inertia of the rod about one of the end points is ml square by 3. So you can place it over here. mgl by 2 is equal to half into ml square by 3 into omega square. 2 and 2 get cancelled out, m get cancelled out, l get cancelled out. So omega is equal to 3g by l root of this. Under root of 3g by l, option B the correct answer. Option B is the correct answer. Root of 3g by l. Okay. Clear? So we are having 8 more questions left out. 24 questions hai. In next 8 we can say 18 minutes we have to cover up. So let's quickly buckle up, and next question on the screen. A frictionless pulley system shown in the figure. Each pulley weighs 40 Newton and the weight W is in Newton. Okay, so that can be lifted by system under the condition shown S. So the question is, what will be the magnitude of W? And they are saying that each pulley is having its own weight of 40 Newton. है ना? तो पुली का अपना वेट है 40 न्यूटन. We are applying a 100 Newton force. So what will be the weight W that should be there under this condition? A simple question. 240, 340, 140 or none of the above? Quickly. Option C. Okay. What about the rest? 240, 340, 140 and none of the above. Simple question. A, B, C. देखो ये easy question है. I don't want anyone to be giving me the wrong answers. See the diagram carefully. Each pulley is having a weight of 40 Newton. Try to draw the FBD of this lower pulley, this one. So this lower pulley is applied with a weight of 100 Newton, right? This will also be 100 Newton. Okay, it is having its own weight of 40 Newton. So technically, what is the tension in this string? What is the tension? Let's say this is T. So what is the tension in this string? So tension in this string will be equal to 100 plus 100 plus 40, that is 240 Newton. Okay, so this is 240 coming over here. So if I try to do the FBD, this will be 240 Newton plus 100 Newton, right? This is W. So W will be equal to how much? 340 Newton. Are we getting option B? I told you, read the question carefully. Many questions will be looking quite like कि question यही होना चाहिए, है ना? Is this clear? Always remember that whenever you are having this kind of problem, try to draw the FBD of individual bodies, then only you will be able to see. Right? Okay? Done? 340 clear everyone how we are getting? Because if you are not taking that into consideration, a 40 wala, then we'll be getting answer to be option C 140, which makes it incorrect. जो basically आपको incorrect answer देगा. Okay? Fine. Done. Option B is the correct answer. Chalo, next question on the screen, question number 18. From industrial engineering, let us try to solve 3 to 4 questions from that also. A supply has 4 sources of 70, 30, 20, 40 units respectively, while the demand at the 3 destinations are 80, 25 and 35 units. In solving the transportation problem, what should be considered? Because we always try to solve a balanced one. This is not a balance, this is an unbalanced transportation model. So where you need to add a dummy source of capacity 20 units to be 20 units is to be added. Dummy destination of capacity 20 units is needed. No solution exists as the problem is infeasible, or no solution exists as the problem is degenerate. Now if you try to visualize what is the total supply or total source, if you try to add this is 70 plus 30, 100 plus 60, 160. If you try to add this, what is this value? This is 40 plus 25, 80, that is 105, 140. Okay, fine. So total net 20 units and need to be added to the destination. Option B is the correct answer. Thank you, Rishi. Thank you. Thank you for that, and definitely I'm very highly obliged by Rishi's comment. Okay, and same to you also. At any point of time, you might be guru to any of your juniors, so you're also, I wish you all a happy Guru Purnima. Okay, option B is the correct answer. Right? Chalo, question number 19 on the screen is from the concept of Quick model. Try to apply this concept. On a cash counter, the average of 15 customer arrives every 10 minutes. So that means the arrival rate is 15 by 10 is 1.5 customer arrives every minute per minute. And the cashier can serve 10 customers in 5 minutes. So the service rate is 2 customer per minute. 2 customer per minute. If the arrival is as per Poisson distribution and serve as per service is for as per exponential distribution, what is the probability that the cashier would be idle? That is simple. Quickly. Option A, B, C or D. A, B, C or D. Very good. देखो पहले तो we will be calculating the value of rho, utilization factor, that is lambda by mu. That is 1.5 by 2, that is 0.75. ठीक है, 0.75 आ गया. This is the probability that the server will be busy, but we have to calculate the server is idle, that means 0 customer, that is 1 minus rho, and that is 0.25. Option D is the correct answer. Option D. Okay, चलिए, done. Right. Option D is the correct answer. Chaliye, next question on the screen. अरे यार, do like the video also. I'm seeing many of the students not अभी तक like नहीं किया है भाई, like भी करते रहिए. Next question. It hardly takes microsecond to like this video. A time estimates of an activity in a PERT analysis. Optimistic time is given 9 days. 9 days. Pessimistic time is given 21 days, and most likely time is given 15 days. What is the approximate probability to complete this activity in 13 days? Quickly, what will be the answer? 16 to 50 or 84? What is the probability of completing this activity in 13 days? A simple question from PERT analysis. Calculate the expected time of completion. TE की value निकालिए. Calculate the value of standard deviation. Calculate the value of standard normal variate Z value, and based on that Z value we can calculate what is the probability. यही step follow कीजिए, get the answer 16 to 50 or 84. So what is the expected time of completion of this activity? That is equal to TP plus 4 times of TM plus TO divided by 6. So 21 plus 4 into 15, that is 60, plus 9 divided by 6, that is 90 by 6, that is 15 days. Okay, so TE value is 15 days, TS is 13. So what is the value, what is the standard deviation? That is TP minus TO divided by 6, 21 minus 9 divided by 6, 12 by 6 is 2, right? So standard deviation is equal to 2, TS is 13, TE is 15, है ना, यही है. So standard normal variate is equal to TS minus TE by standard deviation. TS is 13 minus 15 by 2. This is equal to minus 1. So they are asking what is the probability for the standard normal variate to be minus 1. So probability of Z is equal to minus 1 is equal to 1 minus probability of Z equal to 1. That is 1 minus 0.84. That is 0.16. Or I can say 16% is the correct answer. Option A. Option A is the correct answer. Done. Easy question tha ye to. Chale, next question, 21st question on the screen. In CPM, the project duration can be reduced by crashing. Okay, so for crashing, what we have to do? One or more non-critical activities, or crashing one or more critical activities only, or crashing one or more dummy activities, or crashing activities having independent flow. Crashing kisko karte hain? In CPM, if we want to decrease the project duration, we are crashing which activities without any doubt or difficulty? Option number B is the correct answer. We always try to crash only the critical activities, है ना? If you try to decrease any duration, we always try to decrease the duration of the critical activities only, है ना? Option B. Very good, very good. Kiran, Money, World. Option B is the correct answer. Very good, Pawan. Very good. Next question, 22nd question on the screen. If orders are placed once in a month to meet an annual demand of 6,000 units, what is the value of average inventory? A simple question from the inventory model. A simple question from inventory model. So they are saying that annual demand is 6,000 units. Okay. Can anyone who can tell me what will be the number of orders over here? How many number of orders we need to place in a year? How many number of orders are there in a year? So it's very easy. We are placing one order every month. So number of orders will be equal to 12. 12 orders per year, right? So what is the value of Q? That is inventory. That is your D by N. So D is 6,000 divided by 12. That is 500 units. 500 units. So Q is equal to 500. But in the question, they are saying that what is the average inventory? How we can calculate the value of average inventory? Average inventory is nothing but Q plus 0 by 2. That is Q by 2. That is 250 units. Option B is the correct answer. Here students do commit mistake. They calculate the value of Q and they write it directly like this, which is incorrect. They're asking the value of average inventory. So the maximum is Q, the minimum is 0. The average will be Q by 2. 250 units is the final correct answer. Okay, clear, right? 250 units is the final correct answer. They are asking you the average inventory. If they are saying what is the inventory value, then your 500 will be the correct answer. Done, Nitesh? Clear, Nitish? Because you have responded option D, which is not fully correct. Okay, chaliye. Next question on the screen. From the theory of machine, a footstep bearing and a rotor of vertical turbine forms an example of. They are saying, if you remember, if you have studied the types of relative motion, we are having 3 different types of relative motion: the completely constrained, successfully constrained, or incompletely constrained. So which is the example of footstep bearing? ऐसे करके था ना? It was like, this is your general bearing, we बोलते हैं, we call it as general bearing. We try to apply a force F. Right, if you're not applying a force F, then we're having a translated as per rotation, but now we are having only rotation motion. It's an example of a successfully constrained motion. Syringe wala example आपने देखा होगा, है ना? The general bearing or your footstep bearing. This is option D, the successfully constrained. We are converting this into a constrained motion. That is an example of successfully constrained. The last question. cycloidal gear tooth profile consists of only cycloid, only hypocycloid, cycloid and epicycloid, or hypocycloid or epicycloid? A, B, C और D. साइक्लोइडल गियर कौन कौन से टूथ प्रोफाइल से बनता है? साइक्लोइड, हाइपोसाइक्लोइड, साइक्लोइड एंड एपिसाइक्लोइड, हाइपोसाइक्लोइड एंड एपिसाइक्लोइड. This is just like a tongue twister. Okay, options are just like tongue twister. If you try to say it, A, B, C or D. Perfect. Always remember that cycloidal gear is basically made up of two profiles, hypo and epi, है ना. हाइपोसाइक्लोइड और एपिसाइक्लोइड से बनता है. इफ यू ट्राई टू विजुअलाइज, इफ दिस इज योर cycloidal gear, okay, this is your pitch circle. So the lower profile is basically formed by using the hypo, and the upper profile is being made by the this one epicycloidal. Okay, upper one is epi, lower one is hypo. Hypo कैसे बनता है? When a circle rotates, if I try to visualize, this is your pitch circle, है ना. This is your circle which is rotating without slip. When a circle rotates on an inner side of the your curve, we get a hypocycloid, right? And if a circle is rolling over the curve, we get it as epicycloid. Okay, and your cycloidal gear is a combination of these two, and that is the reason cycloidal gears are very expensive. Cycloidal gears compared to involute gears, they are very expensive, and but the best benefit of cycloidal gear is there is no interference occurring. Interference nahi hota cycloid mein. That is the reason in expensive machineries we are trying to implement cycloidal gear too. Okay, fine. So this is it, the 24 questions from the 3 subjects, and please download. There is a link in the description where you can download the free ebooks, and also you can download and also you can link, there's a description, because there's a link in the description where you can register yourself for the GATE preparation scholarship test. Okay, fine. I'll be sharing this PDF on my Telegram channel just after this session, so that you can all download this, and for later on you can practice. But I would say कि ज़रूरत क्या है, we have solved in the live session. एक बार करेंगे, perfect करेंगे, है ना. We'll be solving the question one time perfectly. But one thing is, for some students have given me some wrong answers in the questions practice in today's session. तो उसको थोड़ा सा एनालाइज कीजिए, एंड वेर यू आर कमिटेड द मिस्टेक, आई होप सो यू हैव रेक्टिफाइड दैट, बिकॉज दैट इज वेरी इंपॉर्टेंट. All this practice we are doing so that in the main examination you are not committing the mistake. Okay, so this is it from my side. I hope you all enjoyed, and please do share this video and like this video too, so that every student will be able to get to know about this, right? So for more such awesome videos and all series, and today onwards we have started for GATE 2024 series for entire subjects, entire syllabus, almost entire syllabus will be covered, which comprises of 50 marks. 50 marks, 40 days mein will be covering from today onwards. Okay, so thank you, bye bye, take care, and let's meet in the next session. Till then, enjoy your preparations with BYJU'S exam prep. Thank you, bye bye, take care.